All right, well, similar figures. That's what we're doing today. Now today we're using the fact that we're given that things are similar. We're not solving whether or trying to determine if things are similar, all right? So that means that this is really just like proportion word problems, except the proportions given in a picture instead of described in a problem. So I think we're going to do pretty good. Moral of the story, long story short. So let's get started. I already wrote the first one up here. So we've got this triangle is similar to this triangle here. Now the first thing you got to do, right, we got a 3-step process. You write the ratio, but in this case, notice I didn't say write the ratio, I said write a ratio. Because a lot of times there's more than one that you could write. Then set up proportion, solve proportion. Or use scale factors. So there's going to be 2 ways to do it. You know I'm showing you both. Even when I'm tired, which is right now, can you tell that I'm tired today? I tell you, but you're worth it. All right, so let's talk. So we've got a couple sides. We're given that they are proportional. And the first thing you got to do is you got to figure out like which sides are corresponding between the 2 objects, which a lot of times you can do just by looking at it. It's obvious from looking at it, like which sides are corresponding to each other. Like in this case, it's fairly obvious that this is the longest side of this shape. This is the longest side of that shape. So JK corresponds to MN. But if it's not, like if you can't tell, you have to lean into the similarity statement. Because the similarity statement, you can't just put those letters in any damn order you want. You ain't got that much freedom. So like the way it's written, by leading off with IJ and LM, that means that the side IJ corresponds to the side ML. And then by going JK as the next 2 letters, that means that JK is corresponds to MN, that they have the same ratio. The ratio between these 2 has to be the same as the ratio between those 2. And of course, if there's only 2 sides remaining, they must also be ready to roll. So first thing let's do it the way I wrote on the board, which is let's just write a ratio. At this point, I could write like 10 is to 9. I could write 10 is to 8.5. I could talk about ratios within the shape or ratios between the shapes. So here I'm going to go between the shapes. So what I'm going to do right away is I'm going to say 40 is to 10. Now I want to make sure, and I'm going to do it using color, right? Because when I set up my proportion, so this is, I'm going to say maybe L for kind of large and small. I don't know. So the blue of the large and blue of the small. All right, so I wrote a ratio. Any ratio you want to write, just write it. Now set up the proportion. Now here's where you've got to match ratios, because a proportion are equal ratios. And the ratios have to be of the same thing. So now I got blue is to blue. So over here, if I want to say get X, I can put X here. Now keep in mind X, if I'm just following colors, right, that's green. So down here I would put 9. Because the ratio of 40 to 10 is basically says 40 is to 10, and the same ratio that what is to 9. Okay, so now I write ratio, I set up my proportion, and now I solve. Lots of ways to solve. I almost get tired of saying that. You know, that's the problem with being a math teacher. So many ways of doing everything. How do I include them all? All right, well, a lot of times you just don't. So this time I'm cross multiplying. So I'm going to go 40 times 9. So if the ratios are the same, then the top number of one ratio times the bottom of the other has to be equal to the top of the other ratio times the bottom of the first ratio there. All right, so we are cooking now. Oh yeah, we cooking with fire now. So we got 40 times 9, 360, so that's going to be 36. Beautiful. The other way to solve this, which is actually more of the way I like to do it, is you just kind of look at it, and once you establish a ratio, just find that scale factor. That's times 4. And if they're geometrically similar, that means a scale factor must exist that maps one side of one object to the other side of the other object. And that scale factor has to be the same. So if you multiply this side by 4 to get that side, then you must multiply that side by 4 to get that side. So 9 times 4, 36. And similarly, okay. Let that hang in the air for a second. You got to multiply 8.5 times 4. That's why they're geometrically similar shapes, because that scale factor does exist. So we go 8.5 times 4, and you get 34. Beautiful. Beautiful. All right. So find a ratio, set up a proportion, solve proportion, or look for your scale factor and just apply that scale factor. All right? Okay. Let's try another one. Okay, so with this, of course, these aren't triangles. This works for any type of shape, below any figure. Notice there's no similarity statement given, because this one's really obvious. They're oriented the exact same way. Okay, so we kind of clearly have corresponding sides here. I'm gonna save blue for scale factor. So let's use the pink. We really have that this side is gonna correspond here. Grab the blue and let's talk about the long side here corresponding there. So let's follow the recipe. Write a ratio. There's more than one you can write. I'm gonna stick today. This time I'm gonna write a ratio within each object. So the ratio of this number to that number. All right? So I'm gonna go 40 is to 26. Make it pretty here. We got our colors. So there's the blue and this is pink. Sometimes color tells a pretty good story when you're trying to teach. Okay, so I wrote a ratio. Let's set up a proportion. I've got to be consistent. I can't just put any damn side that I want here. Nuh-uh. I got to finish. I got to go blue to pink. So over there, X has to be on top. And it's got to be on the bottom because it's a ratio of corresponding sides, okay? And in this picture, the colors are the corresponding sides. All right, I set it up. Quick way, I could just multiply by 8 and I'm done, right? But I'm just gonna continue to cross multiply first. That is the method here. And now we divide. So 40 times 8. I should be able to do that, right? In that 320. Yeah, I'm gonna just do it. I'm just gonna do it. 320 divided by 26. That I don't know. And it is. That's why I didn't know it was a decimal. Okay, now that's about 12.3. Now you can also do these with scale factor. So if you want to use scale factor, what you do is you kind of look at it, and I would just scale here to here. You could scale here to here. But one of the things to realize is that the scale factor is not an obvious number. Scale factor is going to be a decimal. So I might think this. I might be asking myself, what do you multiply 26 by to get to 8? What do you multiply 26 by to get to 8? Now remember, that question is the one that division, hallelujah, division solves for us. I mean, think about it. If you were to say, what do you multiply 5 by to get to 15? What you could do is you write here. Because what fractions do, fractions give you a scale factor. They always tell you, what do you multiply the denominator by to get to the numerator? So if I want to ask myself, what do I multiply 26 by to get to 8? Over here, I got to go 8 divided by 26. That's going to give me the answer. So let's see what we have. So we got 8 divided by 26, 0.308, about, right? It's about 0.308. So that means that is the value that you multiply the denominator by to get to the numerator. So I could come over here and say this is about times 0.308. Therefore, the other way to roll is just use scale factor. We're working with shapes, people. So you grab that calculator and you do 40 times. I'll do it for you here. We got 40 times 0.308, 12.32. It's the same answer. Beautiful. You know, I was gonna do a third example. I think I'm gonna post it here. I think I'm gonna stop at 2. Okay, never mind. I just ended the video with 2 examples, and I remembered why I had written down a third. So, example number 3 is if there's a little expression instead of just a variable. And I think also there's more than one unknown. So let's get a third example. All right, so this is one where students, you see an expression, not just a variable, it's x plus 2, and you see an x in another place. Normally, if I start to see stuff like that, I'm automatically just going to set up a proportion. I'm not really going to think much about using a scale factor technique. So I'm going to look at this. I mean, you could, but I'm just going to look at this and say, all right, first thing I want to do is write a ratio. So I can tell just by the way it's oriented that these two must be corresponding. It's also clear here that we have, let's see, J, K. Can I not read my own handwriting? What's that? Yeah, this would be a J. I wrote a T. I was going fast there. So these two here are going to correspond here. So ST and KJ are corresponding. All right, so that should work out just fine. So let's write 3 is to 4. These are both the maroon is equal to. Now, hopefully these two are also corresponding. So we have RS and LK. Okay, beautiful. They're corresponding. So we're going to have proportional to. Now, 3 is the smaller triangle, so I gotta have the smaller one up here. So I'm going to do x plus 2 over. Sorry, that's the bigger one. Over x plus 2. All right, so let's grab pink. And this is the smaller one, and this is the larger one. Similarly, smaller, larger. Okay, so we set up a proportion. Let's just cross multiply and go home. 3 times x plus 2 is equal to 4x. Cash, distributive property. Move all our variables to one side. Boom! I'm glad I did a third example. Oh yeah, all right. So RS is exactly x, so Rx is 6. LK is x plus 2, so it's 8. Luckily, you're still beautiful. You were beautiful after the second example, and you're still there. Hug your neighbors. Enjoy the blue sky. I'll see you around.